Okay, so now L3. L3 was the part of the quizzes that the students had more doubts. Alright? So let's check the logic first. Let's make sure that we understood what is L3, how it should be built before starting coding. Alright? Checking again. Check the logic, apply the logic on the test case given in the PDF, work it for all test case, then you are with the correct logic to start implementing your code. Please follow these steps. It's going to help you a lot and save time, alright? So, L3 consisting of the longest, this is important, and in the case there are more than one candidate, the leftmost longest sequence of consecutive members of L that reduced to a set is a set of integers without gaps. Alright, so let's see this. What is he saying here? So the longest, well, L3, because of L1, L2, L3 probably is also a list. Alright, so L3, yes, is a list. The longest, it already gives us some tips that this we can have L3 of this size, bigger one, and in case that there are more than one possible, we should choose the longest one. So if we have this guy here would be the answer. Okay. Uh, in the leftmost, so and consecutive members of L, set of integers without gaps. So let's have a look on the test case. So we have here, let me just delete these guys. So we have here 6666048. So 66, this sequence here is this one that he's talking about. However, should this 66 be part of elements to keep? Let's check that. He's not saying, but let's check. This kind of stuff is good to check, you know, because the tests also give you some clues. Here, L3. So I have 15, and 15 is not an element to keep. It's not here, and it's not here. It already says to me that to do L3 does not depend on L1 and L2. So this guy here, L3 does not depend on L2. So you could start your code with L3, alright? Or EK, doesn't matter, because L3 doesn't depend, because you have L, and L is going to be used on EK and to generate L3. Alright? If you have realized that in the beginning of these videos, that's great. And from which one I would start? I would start from this one. Oh, so yeah, sorry. So we have here. Let's just pause the video to write this down. So I would start doing my quiz, from this branch here. I would leave L3 for last. Okay, why that? First, L3 is a little bit more complicated from this branch here to do the L3, and also I would wait some classes to see if Eric would give me any tips. I would talk to my friends. If I did not get the logic correctly, I would come to the tutor sessions in order to understand a little bit more of L3 and to make sure that I can get the logic and then implement L3. Meanwhile that, I would always start with the easiest one. Okay? identify who are the functions that are easier is part of our job. Alright, so always start with the simple one and start doing the most complicated after. So let's go to L3. So L3 here, so we have, he said that they should not have any gaps between each other. So if we realize that 6 6, the difference between them is 0, here is 1, correct? Also, so let's see the next. I cannot get much more information about this. So these guys here, let's go back a little bit. This guy 6 6 is a sequence here, and 15 14 is this sequence, so doesn't have any 1 in the middle. Alright, maybe this is the gap that he's talking about. Let's check that with other test examples. So 3 3 4, these guys are here, the sequence doesn't have any 1 in the middle. Here 3 3 doesn't have any 1 in the middle. 6 5 6 also doesn't have any 1. So L3 4 8 7 6 4 7 5. So this sequence also doesn't have any 1 in the middle. So when he says with no gaps, it means that amongst the sequence I cannot have, for example, this 4 8 7 couldn't be in this way, like 4 8 11 7 6 4 7 5. This 11 would break the code and would have other answer instead of this one. Alright, so with no gaps means that in this sequence all elements should be should be consecutive, which is incremented by 1. Let's check if it's right. So I have 4 here. We said before, in this case here, if you remember, the next guy, the difference is -1 or +1, or the absolute value between two consecutive numbers should be at most 1. Right? However, it breaks here in this case. Where is that? In this case here. Why? Because the difference between 4 and 8 is 4. However, for this 4 I have 5, and the difference for this guy is 1. Then 5 I have 6. Then 6 I have 7. Then 7 I have 8 here. Alright? How do we check now if in a sequence they have someone that is the next guy is consecutive? Well, the only way to do that is to order these guys. Alright? This was one trick of the L3. Alright? That you should realize that. Let's order. So I have 4. I have 4 again. Then I have 5. Then I have 6. Then I have 7, 7, 8. Alright? So what is the difference here? 0, 1, 1, 1, 0, 1. So the difference between this guy and the previous one should be at most 1. Alright? However, we can do this code to check this. That's fine, it's one possible solution. But to make it easier, let's get these guys here and let's remove the duplicate values. So we have 4, 5, 6, 7, 8. So this guy to the next one is 1, 1, 1, 1. Because we do not have duplicate values, it should be always equals 1. Here, the difference between xi plus 1 minus xi, the abs of this value should be less or equal than 1. Okay? But here what we can do is that xi plus 1 minus xi is equals 1. Alright? Should check that. That is equals 1. If it works for everyone up to the end, then this is a possible result. Alright? What do I mean by possible result? Is that if we have a list like, let me get some test case first. 2, 7, 2, 6 nodes, not a good example. 0, 2, 1. Else, I don't want this guy. 0, 3, 3, 4, 0, 1. No. Okay, let me create a let's check other one. 6, 6, 4, 8, 10, 15, 14, 3, 3, 4, 0, 3, 0, 1. This one is good. Alright. So what are the possible results from this guy here? Okay, we have 3, 3, 4. That if we apply this logic here, this is a valid list. Alright, because it's going to become, this guy is going to become 3, 4. The difference is equals 1, so it's valid. Alright, just this logic here. However, if you realize, we also have 3, 4, which is a subset of this one. This is also a valid list. Then we have 0, 1, 0, 1, which is also a valid list. So we have this guy here, we have this guy, which is possible, and we also have this guy. So from his specifications, he said consisting of the longest. This is what he means for the longest. Who is the longest one? Is this guy, because this guy here has 1, 2, 3 elements. Alright? This guy has 2, and this guy also have 2 elements. And going a little bit further, in case there are more than one candidate, the leftmost sequence. So if we had here a sequence, let me create other example. 1, 2, 3. Right, simple one. Then we have 5. Let me. So let's put. Oh, great. So let me create this one. 7. All right. Then 0, 1, 2, 3. Then 9. Then 11, 12, put 13 here, and 12. Okay, so this guy here. Let's put here 14. Okay, so here we have this sequence. Alright, we also have this sequence here. Alright, this sequence has 1, 2, 3, 4 elements, and this sequence also have 1, 2, 3, 4 elements. And he says, in the case there are more than one candidate, the leftmost longest sequence of consecutive members should be considered, right? So he means that who's the leftmost is this guy here, all right? Because this guy is more to the left. Okay, so in the case that we have two possible candidates and these guys have the same size and they are the longest one, choose the leftmost side. Okay, all right, so now that we understood the logic, let's implement this. Okay, how do we do that? This is a bit tricky. So let's start. How do we build this? So let's suppose that I want to check the elements from 4, starting from 4. So 4 is a possible result. Yes, because it's only one, it's consecutive, and that's okay. So it's a possible result. 0, then 4, 0 is possible? No, because the difference between them is 4, right? So this guy here, when we get 0, is not possible. Let's continue. So I put 0, 4, 3. Is this possible? Well, 3 to 4 is plus 1, but to 0 doesn't have any 1. So it's not possible. Then let's add one more 3. 4, 0, 3, 3 is also not possible. 4, 0, 3, 3, 4 is also not possible. 4, 0, 3, 3, 4, 0, 1. 0, 1 is at most 1, but we don't have 2, so it's not possible. And 4, 0, 3, 3, 4, 0, 1, 3. So we do not have 2, so it's not possible, right? So we tested everything from 4, alright? However, I need to test a sequence that starts now from 0. So I have 4 here, alright? Now I'm going to do for everyone start from 0. So I have 0, then 0 is a possible solution. Okay, this guy is not possible. Then I add one guy, 0, 3 is not possible. 0, 3, 3 not possible. 0, 3, 3, 4 not possible because I don't have 1 and 2. 0, 3, 3, 4, 0 not possible, don't have 1 and 2. 0, 3, 3, 4, 0, 1, 3. Alright, I will imagine that I did for everyone. Doesn't work for everyone because I don't have 1 and 2. So now I found all possible results for 0. So let's keep these results, alright? The possible results that we have. So I will put here possible results. Alright, imagine that this is a table. What we have so far? We have 4. Alright, then we have 0. Okay? Now I have to find all possible results from 3. So I will continue here. Alright, so I have 3, these 3, okay? So I have 3 is a possible result. So 3. Then 3 is also possible. 3 3. Then 3 3 4 is also possible, because when you reduce to a set is 3 4, difference is at most 1. So 3 3 4. Alright, then let's put 0. 3 3 4 0, this one is not possible. 3 3 4 0 1, not possible. 3 3 4 0 1 3, not possible. Alright, so if you keep doing this, you are going to see that doesn't have all other possibilities are not possible. Right, only, I mean, like for this one is possible. So we are going to have here this same guy, 3 again. We are also going to have 3 4, which is valid. Okay, then we are going to do for this 4 everything again. 4 is valid. Then 4 0 is not valid. 4 0 1 is not. 4 0 1 3 is not. Then we are going to have 0. Then 0 1 is possible. Alright, for these guys. 4 0 1 3 is not possible. Then we start from 1. Then we have 1 3. Alright, so we have all these possible results, and he says, first check, get the longest one. The longest one. So what is the size of this guy? So this one has size 1, size 1, size 1, size 2, size 3, size 1, size 2, size 1, size 1, size 2, size 1, size 1. Alright, so the longest one that we have is 3. It's only 1 3. So the answer is 3 3 4. Let's check. 3 3 4. That's correct. Alright. L3 is a bit longer, the logic. Again, you should test this, if this logic works for all test cases before starting coding. Alright. I will jump this part because otherwise the video is going to be too big. Alright. So let's start coding this. So before we start in coding, what is our approach? So for each element of this guy, we see all possible results from this guy. Then we see all possible results for this guy. Then for all possible results for this guy. This guy here that I'm saying is all this guy here. Alright? So we have a for loop on this guy. And then other for loop is starting from here to the end. Then the first for loop is starting from 0, and the other for loop starting here. So we have a for loop inside a for loop. How do we do that? So let's implement that.